All right. So we're going to go a little bit more detail into structs and then talk a little bit more about the project. Just make sure people fully understand what the project looks like so you'll be able to code it yourself. Any questions on anything before we get started? Okay, so let's do a recap on structs. On Wednesday, we talked about if we had a Morehouse student, what kind of information might we want to store about that student. You all came up with stuff like classification, what classes they're taking, their ID. We made it a string because there is like an M in the ID number. Credit hours, dorm name, student name, whether they're living on campus or not. Why could we not store this information in an array? Yeah. An array can only store one kind of data type. Arrays are typically good if we have everything's the same type and we want to do some sort of processing, because then we can use a for loop, add all the numbers together, or print everything in the array. But if we have varied data types, then we have to use something else that's called a struct. So to create a struct, it's essentially like creating a new data type. So how we have data types like strings and bools and doubles, now we could create a data type that's called like Morehouse student. And this data type underneath of it would have these different variables. So in memory, it looks very much like an array. They'll have continuous blocks of memory. The difference is they can be different data types. So it might be different sizes. The way you could identify how large an array is, you check each of the check how big a struct is. You see how big each of the variables are inside of it. So at strings, it's a little bit hard because strings are variable length. But if we had like a double, an int, and a bool, then we'd know like the double is 8 bytes, the int is 4 bytes, the bool is 1 byte. That struct would be 13 bytes large. And so then later, when we want to create a variable student, we, just like how we define any other variable, we say what the data type is. So in this case, the data type is Morehouse student, and then we put the name of the variable. Questions here? Okay. So now if we want to actually get elements in a struct, we use what's called dot notation. So again, if this is our struct, if we wanted to set the name of the student in this struct, can anyone guess what that would look like? Okay, student.name, and then what? Equals whatever name we want. So essentially, it would look like that, student.name. So essentially, like when we imagine the struct, right? If we had, that's a lot of stuff up there. Tic-tac-toe, this would be a 2D array if we were creating it, 3 by 3. Okay. So if we had this struct Morehouse student, in memory, it would look like this. It would have 4 boxes in this struct. 1, 2, 3, 4. Though I guess technically this classes one would have a lot of like little spots because it's an array. Let's write in a color that's a little bit more legible. So normally if it was an array, we would have indexed it. We would have had 0, 1, 2, 3. In this case, we just referred to them by their names. So this would be like the class's position. This one would be the ID position. This one would be the name. And this one would be credit hours. So when we say, and the overall thing is student. So when we say student.name, which box are we referring to? This one here. Yeah. So essentially it's like anything we can do with a variable, we can now do with student.name. So we can assign like this variable box to a value. So when we assign it equal to the string ash, what happens in our memory? Yeah, so essentially ash gets stored as a string. Yep. If we wanted to do student.credit hours equals 16. What's going to change in our struct memory?
Credit hours is at least 16.
Yep, we put a 16 in here. So then if we want to see out this statement, what is going to be printed?
Ash has 16 credit.
Yeah, so like student.name is going to be Ash, has, this is 16, so Ash has 16 units. Any questions here? Okay. Yeah.
So the struct is not assuming it's its own function?
It's essentially its own data type. We've defined a new data type called Morehouse student that has these 4 variables inside of it.
So would that all go from the main function?
It can go inside the main function, yeah. Yeah, so that's a good question. Like, where is this actually defined? Okay, that's a good question. You can define it outside of the main function. You can define it inside. It's kind of up to you and what purpose you want. In the Strategic 7's final project, we define it outside the main function just that it can be used by any file. Yeah, we don't have to worry about that nuance as much. The big takeaway I want you to have here is like somewhere we have to define this new data type, and then after we define it, then these 4 lines would for sure go in like our main function. We would create like a Morehouse student, and then we could do these manipulations on it. Okay, other questions? Cool. So just to really drive it home, the difference between arrays and structs, how we get elements. The way we get an element in an array is with indexing. So if we have this names array of size 3, how could we set the name Ash to be in that 0th element of names? Yeah, so we'd say names of 0. So this is what we call indexing when we put this number inside the square brackets. We do it with strings as well. If we want to get a letter in a string, we do the name of the string, square brackets. Same with arrays, right? And then if we want to print out Ash, we would see out names of 0. For structs, we use dot notation. So as we said before, it would be student.name is equal to Ash, see out student.name. Yeah.
So you have to have another variable next to the name of the struct? So like how it says Morehouse student.
So this is like essentially, it's the same syntax for if we were to define a normal variable.
Right.
Like normally we would say the data type and then the name of the variable.
So technically Morehouse student is the data type.
Morehouse student is the data type, yeah. We've created a new data type called Morehouse student, yeah.
Okay.
Other questions? Yeah, I think that's the big takeaway with structs. We're essentially creating a new data type that we can then use anywhere else in our code after we've created this new data type. Okay. Sweet. All right, super critical. This will help you a lot for the project because we give you this game state struct. We're going to talk a little bit more about that game state struct in the 3rd section, but understanding structs, I think, is pretty critical. And I think it is relatively straightforward. You just have to understand we are creating a new data type, and then we use dot notation to get the actual data from this struct. Final questions? Sweet. So I'm going to have you all play the game again. When we played on Wednesday, we're trying to win the game. This time your goal is going to be to try to lose the game. Okay? Just to recap the rules, can someone, what's the point of the game? What score are we trying to get to? Yep. We're trying to get to 200. What can you do on your turn? Okay. Once per game, you could double your score from the turn. What's your other power up?
Erase your last roll.
Yep. Once per game, you may erase your last roll. On a given turn, how many times are you allowed to roll the dice? You can roll as many times as you want. What's the risk if you keep rolling? Yep. You run up your turn score, but then you hit a 7. Your turn score goes to 0. Yep. Okay. So take 2 dice, pass it around, partner up with someone near you. And in this case, we are trying to see who can lose the game. and then we'll come back together and see what strategies people came up with to try to lose the game. EJ, if you can grab a couple dice and then pass them along. If you need paper to keep track of score, let me know. All right, we'll go 1 more minute. Okay, finish up your last turn. Okay, let's come back together. Okay, what scores did people end up getting up to? 0, 18, a lot of zeros. Okay. All right, let's stop rolling the dice, please. Thank you. All right, how many people used their double power? All right, when did you use your double power? Okay, what was your turn score when you doubled it?
I had an 8, and then I used erase and doubled to 0.
Okay, so used the erase when a roll was the 8, right? And normally in a good strategy, when would you want to consider using your erase? When you roll a 7, and then ideally also if you have a lot at stake, right? So use the erase when the roll was the 8. We can generalize this to like not a 7. All right? And then, so essentially your turn score was a 0, and so use the double score when turn score was 0, right? That's essentially wasting our double power if you use it then. All right? And then when were people ending their turn?
Never.
After one turn, after one roll.
After one roll. Okay. So that's not a great strategy, but I wouldn't say that's the worst strategy. Because you're always locking in some points, and eventually you would get up to 200 points. Right? Like if you roll a 9, you lock that in. Then you roll a 3, you lock that in. So you would eventually get to 200. What's like a worse strategy than that? Yeah, essentially like keep rolling till you bust. Right? In lab, how people are setting that up is like, if the turn score is greater than 10,000, then stop rolling. Because it's like, what are the odds you're going to get up to 10,000 without rolling a 7? So, yeah, I think people kind of figured it out. When I was watching, people essentially just kept rolling till they got the 7 and they busted. For this part 1, it asked you to create the worst player strategy. You can take some of the things you learned from this class activity here. Any questions here? Okay. So let's talk a little bit more about structs, but this time in the context of the project. So we're going to talk about the game state struct. Last class, we were talking about information that would be useful when you make your decision on whether to erase the roll, double the score, or stop rolling. Essentially end your turn, right? And we said it's dictated by what power-ups you still have available. Like if you still have your erase roll power, then maybe you can be more aggressive with the rolling. If your opponent's score, if your opponent is very close to winning, then maybe you have to be more aggressive with your rolling. Like if they're at 198 points and you're at 50, maybe you just have to keep rolling till you get 200 and you have to hope for the best. Stuff like turn score is important. Your current roll sum, like if your current roll sum's a 7, then maybe you consider erasing the roll. So this is all information that you can use in your functions when you decide what to do. And if we pass in each of these variables by themselves, we would have 9 different function parameters, which would be pretty messy and not very good code. So instead, what we give to you, for example, in should end turn, we just give you one parameter. And what is the data type of this parameter? The parameter is game state. So you can use this variable game state with dot notation, and you would have access to all 9 of these data fields. Does that make sense? Okay. The way that we initialize struct values, you don't really have to worry about this. We essentially create this code for you, and we take care of this, but just if you're interested what it looks like to initialize a struct, you say, it almost looks like an array, like we say what the data type is, we say the variable, we put the equals, and then we put these curly braces. And we put like the 9 different values in this case. So we have other variables that, like winning score, in your lab, you set winning score equal to 200. Current roll.get dice sum, this gives us the value of the dice. So we're essentially getting all this data from different sources, and we're putting it together in this one game state variable. And then we give you the game state variable in the function for you to use. Any questions here? Yeah.
So like if we were to call current roll dot get dice sum, we would have to put game state dot current roll dot get dice sum, or how would that?
No, so these are like the actual variable names.
Okay.
So you would just have to say game state dot current roll sum right here. Yeah. Good question. Other questions? So there's a file in the project called like gamestate.cpp, and it has this. So you can always refer back to that to see what the names of the variables are. And ideally, we've named the variable names appropriately that you know what each of them do. Yeah, go.
So I see there were 2 different game states. One, I think, is that like capital camel case or something?
Yeah, so when we define the struct, we generally do upper camel case. But then when we use like the variable name, like you would be using this variable name. And with variable names, we do lower camel case.
So to call the current role, you would do the lower camel case dot current role.
Yep. Because this, you could almost think of this as being like double number. And we would use like number as the name in the function. Again, this like capital game state is just the data type. And then this is the one that's actually the variable name. Yeah. Good. Other questions? Okay, so let's do some code together. Essentially, all of your functions at the end are going to return false. Like essentially, in the default case, we never use our power-ups, and we essentially never end our turn. But we just saw if we always do false for all of them, we're never going to score any points. So when you think about setting up your functions, you're going to have a bunch of if statements before the false. Essentially cases where you do want to end your turn. So let's think of one case together where we might want to end our turn. Let's say we had like 186 points. So user score, like a game state dot user score. Let's say that was 186. Okay? So that's what you would have written down on your paper. We do the first roll. One thing, so I'm going to have you all play the game again at the end of class. And I want to encourage you to keep track of stuff in this manner. So, like, take your phone out and you would have your calculator app. And the calculator app is essentially going to keep track of your turn score. So when I roll the dice, I get a 10. So I'd put 10 in my calculator. So I'm not writing anything down on the paper yet. Only write stuff on your paper if that's part of the permanent score. Okay? So we have 10, essentially there. And then I roll again. Okay, there's another 10, but we'll mix it up so it looks different. 6. Okay. So at this point, we have different variables. We have game state dot user score. That's what I have on my paper. Let's say it's 186. We have the turn score. This is what's currently on the calculator. So what's on my calculator right now? Not 16. On the phone calculator, 10. And then game state dot, what do we call it? Current roll sum. Current roll sum. That's what's on the dice. So what's on the dice right now? 6. So essentially the way the code is set up is when you make the roll, that's when we ask you what you want to do. So your turn score isn't actually 16 yet because we're waiting to see what your decision is. Like if you decide to erase the roll, then your turn score is still at 10. So essentially after you roll, you have access to these 3 variables. You have your user score, you have your turn score, you have the current roll sum. In this case, what is the optimal move for us to do? What was it?
To lock it in.
To lock it in. Why do we want to lock in the score right now?
We're 80 or 86. Your score is greater than 200.
Yeah.
Collective score.
Like if we add all 3 of these together, our total score would be 202. And we've won the game. If we didn't lock this down and I rolled again and I rolled a 7, my score would have stayed at 186. Right? So if we were to create this if statement, what would the if statement look like here? In what case do we want to return true to end our turn? Yeah, so first let's think about what would the score variable be equal to? Yeah, but using the variables that we have in game state. I guess like if we wanted to calculate like our total score including everything that we've accumulated this round. Like how did we get to 202 just now?
You have to add it.
Yeah, we have to add all 3 of them together, right? So essentially like if the game state dot turn score plus the game state dot current roll sum plus the game state dot user score, if that's greater than or equal to the game state dot winning score. then we know we want to end our turn. I'll leave this up for a sec. Do people have questions? Yeah.
So to win the game, it would be 200 points. It would say game score equals 200 points. If user score is greater than or equal than 200, then the answer is true.
Yeah, so essentially this function is asking like when we should end our turn and stop rolling. And the way, in this case, like if we were playing live, we would have ended this turn. And yeah, because it was over 200. But the way we knew it was over 200 was we had 186 written on our paper. That was our permanent score. We had like 10 on our calculator because that was our turn score up to that point. And then we had 6 on the dice. And if we added them all together, then really our like real score at this current state is 202. And so because that score is greater than the winning score that we're looking for, the winning score is 200, then we know return true. We want to stop rolling, lock in the score.
Oh, so you wouldn't actually use the numbers in this situation. You have words, keywords for everything.
Yes.
So you don't have to say if it's greater than 200, you would just say if it's greater than the winning score.
Yeah, like winning score. Because later if we want to play the game to 500, then our code would still work if we generalize it with
So
this.
that's making the words more compatible.
Mhm.
Okay.
And then the reason why we have to use words up here is because these values are always going to change. Like we can't say +6 because what if I'd rolled like a 10? Then, you know, it's a different value. But essentially the value is stored in, like this dice sum is stored in this current roll sum. All right, questions here? This is essentially the crux of the project. So like we would have one if statement here. Let me open up the Scratchpad. Okay, I'll get into final project. Okay. So essentially, like all of these are returning false as the default. Like the default move is that we're never going to erase the roll, but then we would essentially in our code write different if statements for the specific cases where we do want to erase the roll. So we would say like if something is true, and you get to figure out what that is, and you get to experiment with what works best. So we had said maybe as a start, if game state, like we said if the roll is 7, right? So how can we get the current roll? Yeah, dot current roll sum is equal to 7. Then we might return true and decide to erase our roll. The way functions work, as soon as a return statement is hit, the function immediately ends. So once we return true here, the rest of this code doesn't run. We don't have to say like else return false. Once we return true here, that's it. We've made our decision, we've locked it in, the rest of the function stops. Okay? This might not be a good strategy though, because what if your turn score was a 0? Then at that point, if you roll a 7, maybe it's okay to just lose the points. So you would have to do more work here. So that could be one if statement. Then if you think of something else, you can do like another if statement. So you would have like another case here. And if that part is true, then you would return true. So it'll check this condition first. If that's true, it'll return true. Then it'll check this one. If this one's true, it would return true. Otherwise, if it made it to the end, then that meant, you know, we're just returning false and we're not going to erase the roll. Do people follow? All right, now would be a really good time to ask questions if you don't follow, because this is the crux of the project. The order of these if statements matter. So if we wanted, we could have, if there is a specific case we wanted where it returned false, and then the other ones where it returns true, it will go down this chain in order. So essentially, like this is the top priority if statement, this one will run first, and if it returns true, then nothing else will run. Then it will check this one. If this one is, like the condition is true, then we would return false, nothing else would run. Yeah, questions?
So you can come up with as many strategies as you want, or is it
So essentially, you're going to create these different player files. So you would come up with your first strategy. Let me reset to the scaffold. So I have like a 5-minute video that kind of walks through first steps on how to get started. But in this main file, once you run your code, it's going to tell you like your player and then how well you did against different bots. And right now, this player is not doing very well. The win percentage is like 8% against the medium bot. Then you'll create like a new player file. Instead of Ashwin1 player, like if you create yours like Ronald Smith player, right? And then you'd switch the name to Ronald here. And then you would run it again. And then you would see what your win percentages are. You would see what worked well, what didn't. And then you could create like a Ronald Smith 2 player, then a Ronald Smith 3 player. Ideally, we want you to create at least a few different players, just that we see some improvement. Right? The other nice thing that we've provided, right now this just gives the raw winning percentages, but if you want to see what the game actually looks like, then you can use this function instead. Play 1 versus 1 game. And if we run this one, it'll tell you after each roll, it's going to ask like press enter to get the move. And it'll say like Ashwin chose to end their turn, they scored 0 points. Then it says hardbot rolled a 9, it says what they did, and then it says their score. And you can kind of keep going turn by turn and see what moves are being made. And this can help you debug, is it making the moves that I would have made if I was playing the game personally? Okay. Cool. And again, the 5-minute video has more details on how all that works. Okay. Questions on anything here? I will say part 1 of the project was a little bit confusing because we had you change a lot of parts in the actual game. Part 2 is a lot more straightforward. Part 2, you're only creating these 3 functions. Should erase roll, should double turn score, should end turn. Essentially what we do when we play in class. Yep. Okay. Other questions? Okay. Yeah.
So the user has erase roll power. That's only able to be used once. Will the code know that it was used once already?
Once you've used it once, yes, and we won't even, essentially once it's been used, then we won't even call your should erase roll. So you don't have to worry about checking in here, like has the erase roll power been used or not. We do that check for you. Where you might want to use the power though is in the should end turn, because it might dictate how aggressive you are in rolling if you've already used your power-ups or not. Good question. Other questions? Okay. Cool. Okay. So I'm going to have you all play again. But this time when you play, so this time you're going to try to win again. I have paper for you to keep track of the permanent scores. When you play, though, I want you to kind of keep track how we did here. So you have like your calculator app that keeps track of the turn score. You have your dice that keeps track of the current roll sum. And then you have your paper that keeps track of your actual user score and opponent score. Right? And I'm going to come around while you all are playing and like pause the game and ask you what your game state looks like. And you should be able to answer what values would be stored in each of these variables. Okay? Any questions? Okay. This time you're trying to win, trying to beat your opponent. Christian, you can come up again. Kelvin here.
You got paper.
Yeah. Yeah. Playing around piece of paper. Again, use your phone calculator to keep track of the turn score. Only write stuff down on paper that's your permanent score.
You can go back to 0 unless you want to get 47 points and erase the roll. Erase the 7. It's up to how you want to play. If you want to erase it, you get 27 points, you can erase it. Or you can
Double the score.
just keep rolling. you would have to use your one erase, and then keep rolling, keep rolling.
So what is your game state that you use? One more. I ain't gonna lie. Keep that. What is that? Fuck. 7. I know, I'm telling you, I ain't got no pressure. 7. What you want to do? Let's pause here, right? Alright, let's go together. What's 10? Okay, now towards like Erase that. Oh my God, what? Yeah, keep it 29. Erase the 7.
I'm gonna erase it.
Come on for that. 6. Oh yeah, first. Great. Ball got me good. You double.
Lock that in. Lock that in.
What you want to do? What you want to do? You erase it? I don't want to erase. Oh my God.
You're right.
No way. That is crazy. I should have kept going. Wow. Man, restart. That's a good game. What the? We had it in the bag. What is?
Hey!
so now you're essentially making a decision with
I could have rolled again, but I was like, I ain't never been that sick in my life.
Erase. I'm using that right now. 8. Yeah. Go big, go home, man. I would be like, 5. Yeah, I gotta get that 80 ball. I gotta get that 80 ball.
Okay. So right now,
Oh, hey, what that dice roll?
They rolled it too.
Oh! Oh my God. 76.
So right now we're trying to run around 90.
Yeah.
I ain't gonna lie, I had 7. The way I just lost the last game, I had 1.
Have you used any of your powers? Okay, so your has a raised roll power would be false. Your user has double turn power. Like Calvin, what is the opposing like that? Or sorry, like we're talking from this person's turn right now. What is all? Have you used that in your power? Nope. Cool, so you would still be, both of those would be true. And then the turn score, I think it was like 14 on the The turn score was 14. What was the current right? So essentially using all this information, you're now going to make a decision. Do I double? Do I send return? But essentially all that data is stored. Alright, let's also have you all look up here so that we can see this here. Alright. So what is your user score? What do you have? Okay. Have you used any of your powers? So both of those are using
Now you paying attention.
User has double turn score power.
Yeah, then I hit 6. Then I wrote the next one. Then I, you know,
0 and your opponent
use my ring.
the erase. So opponent has a race roll power, would that be true? Or it would be false because like has the power and you don't send it. And then has double turn score power, that one would be true. And then what is the turn score? So that's what we type on the calculator. Turn score is 26. What is the current score?
7.
7. So essentially we have all this data, and now we're gonna call like should or rate, and maybe we will. You have a 7. Then we're gonna try should we end the turn. Right? We're gonna call these questions, and you're gonna have this data available. If people want questions,
Go ahead, burn 'em.
Make sense?
Okay. All right, let's pause the games really quick. Sorry, let's bring it back.
Come on! Come on!
Okay, let's pause. Okay. I think people are hopefully getting it. User score, that's what we have written down on the paper, right? Opponent score, that's what your opponent has written down on the paper. Turn score is what's on your calculator for the given round. The current roll sum is what's on the dice. So you're going to have to do combinations of these. Like when we checked if the overall score was over 200, we had to essentially add these three things together. And if those three things added together were greater than 200, then we decided, yes, return true. We want to end our turn. It's up to you to figure out these different cases in which you would want to return true. You're also going to have to play around with different thresholds. So right now, people are maybe saying, like, after 5 rolls, I'm going to stop rolling. Maybe people are doing it in terms of value. After 20 points in a turn, I'm going to stop rolling. I personally don't know what's best. But the nice thing is we can simulate thousands of games, and you can figure out what the best thresholds and values are. Right? So that's the point of this project. Experiment. Just experiment with different values. You're not going to come up with the best strategy on the first try, but hopefully you have fun trying to think of different strategies. Okay? What's due? Again, if you haven't come into lab Wednesday or Friday, make sure you come in today. Super critical lab for the final project, and then homework 10 due later tonight. Cool.
Double that.